All right, time for a draftphysics.com, debatephysics.also.com, video presentation and such. Forgot how to do this. What am I supposed to hit now? Ah, there we go. Button. So nicer weather. I haven't been out planting my food source. So, anyway. So Dispar Lab has made a video, okay, saying something like a proposal for a possible experiment, blah, blah, blah. Who knows? Ian Gosling was supposed to have another great experiment. Haven't seen that yet. But anyway, this whole free energy thing. So I've already been over this. This is the way to do it. So I haven't watched the video yet. So we'll see what his proposal is. But to me, it's a pretty simple idea. Once you get through all the bullshit, and figure out how to do this right. Now, their argument is that you can make essentially free momentum. You can put 100 momentums in an object, and you can get up to 200. Okay, so let's just say 150 to 200% of the energy coming out. No, that's the wrong way. That's what it is. There's a percentage. So you can get 150. You put 100 in, get 150 out. That's with a 3-mass object. If you make it a 5-mass object, you're going to get a lot closer to 200. So you'll have a free, extra 100 momentum in the universe. And I say, yes, can happen. Physics doesn't allow that. Obviously, that would be collectible, in my opinion, okay, with a lever, and you could just end up creating lots of free energy and perpetual motion and all that stuff. So the fact is, this doesn't go 3/4 of the velocity of this object. It only goes half the velocity, and it's just a matter of measuring that. Okay, so I've suggested that all you need to really do is establish the height that something falls from. And once you have the heights established, then, this game is sort of over. I said before that, doing it from this bottom, but really what you want to do is to do it from this center of mass. So from the center of these masses, where they hit each other, you put a little block next to that. And then you establish that height from whatever your platform is. Okay. So all this stuff has to be level, obviously. And once you have that height, then you go, 1/4. Well, you take a distance, okay? So this much added distance here, okay? We'll call that 1. And then you just say, all right, I make the same platform here at the center of mass, okay? And I just make 4 of those, okay? 4 of those. And that'll be my 4 times the height, okay? And all I really have to do is back this up just a hair. Okay, so this doesn't hit it. But the idea is you put the ball, pull it all the way up here, have it rest on top of this platform. Then you just move this back a little bit and it falls. And you should get a pretty consistent measurement. Now, you should be able to test that. He has little timing gates. You can just let it swing back and forth. And you can see how much energy it loses with each swing. Get lots of good details. And that'll be the incoming velocity. Like I said, we don't need to know it, but I just mean it would be interesting to know all of that. And the simple fact will be this will swing down, and when you have your 3 mass here, it's going to reflect. Okay, it's going to hit and reflect, and if it reflects all the way up to the top of this this 1 block, well, then you have 1/2 the speed. So you've established that this reflection was half the speed. We know the 2 objects move off at the same speed, so then you would have half the speed going the other direction. So if you get back far enough to get to that distance, you'll have accomplished your task. Now the fact is, he's doing this on a very small pendulum, 10 inches or less. So the arc is rather extreme, which means the heights, get radically higher as you go up. And so a small amount of distance can be 4 times the height difference, especially over here in the arc. So anyway, so you do have to be very careful in terms of setting it up and filming it and all that stuff, but that'll get you the answer. So this is the 4th time I've suggested something similar to this. And I mean, I'm just saying, theoretically, I can't find too much wrong with this experiment. From my perspective, it seems to qualify to, if this does go all the way back to this height, that does have to be half the speed, half the velocity. Again, you could test it with the blocks and just make sure this is full, this is half, then put this one in place, and when you get your reflection, you'll be able to see if it's equals to half. Doesn't seem that arduous to accomplish this task. Okay, now, I haven't watched his recent videos because they're just too obnoxious, and he just keeps claiming he's decidedly proving something by taking frame rates and doing all this other stuff that we already know is kind of suspect. I don't even think the objects he's using are round. So, I mean, that's part of just looking at the icons. You could see all kinds of distortion. Well, the distortion is, I think, they're turning because they're not, they're they're oblong, not round. So that is not ideal. That's all I'll say about that. All right. So, interesting. Yeah. Going to do some solar experiments. Anyway, yeah, so that's okay. So I'll pause here and bring up the video. So my Firefox is still broken. Can't see my subscription. So yeah, that does trigger me a lot less. So that's the good news. So I can't watch, so YouTube is discouraging me basically from watching videos, besides making it impossible for me to comment on any. But it is, it is annoying that I still can't view my subscriptions, and I have to watch videos in a private window, But anyway, this is YouTube. The internet, it's just so fucked. Alright, so here's the video. 4 Draft Science, Newton's Cradle Experimental Proposal.
And, measure its peak velocity.
So I really hate people playing quote mining videos. It's just so bullshit, frankly. Either play it or don't play it, okay? Either deal with all the arguments made in the context they were made, or just fuck off. But anyway.
So we find a position for the timing gate, okay? That's at the bottom, likely at the bottom of the slope. That's the highest velocity that you can get.
Alright, so now he shows an overhead view. So this is a proposal of some kind. You're just going to do this crap, whatever this crap is. So this is some previous experiment. Again, you just keep doing the same shit. Resting position, the timer is right below the small ball. So again, I told you the timer, putting them between the 2 balls didn't work because you didn't get the right velocity for the incoming one. So the whole thing was moot. Oh, fuck. You've got to establish the velocities. You got to show that the damn thing even works as a Newton's cradle. I mean, there's no point in saying, look, it's half the velocity, or it's half the energy, or twice the energy, or some form of the energy, when you haven't even accounted for the fact that it loses 20% of the energy with each click. So we haven't even seen if this Newton's cradle can survive 10 impacts. 10 impacts mean, if it dies in 10 impacts, that means you're losing 10% per hit. So if you're getting twice that, I got half the speed. Well, if you're getting that high a velocity, then you did something wrong, because frankly, the velocity should be 10% less than. Dumbass. So I didn't want to watch any of these crap videos, and now he's going to play them again anyway.
You allow the object to just swing on off of it. So you just move this away, the ball falls off, and you should get a pretty consistent fall, okay? So the idea will be to do it from a certain height. You can do it a few times, 5 or 6, you find out.
Just amazing. So he doesn't do any of this stuff.
Whether you get the same exact speed, all right? Then you're measuring a very precise speed. And then you just do it with different heights. and you find a height that...
I wish you'd get ready. Can't you do something about all these watermarks on everything?
It's exactly twice that speed.
Fixed height, one velocity. This is just bullshit. This is a waste of my time. You never did a fixed height, so I don't even understand what you're talking about. When did you demonstrate that you always just lifted and dropped it? Where's your fixed height in here? Yeah, so instead of doing it the way I suggested, which is now where's half the speed? Is half the speed in the video? No. So instead of doing what I suggested, which is have the half speed mark also in the picture, so you can see exactly where half the velocity would be. It's an arc again. I don't have to explain this again, do I? It's an arc. Measuring this distance without doing the precise math for the angles is useless because it's not linear. It's traveling an arc. It's going into more gravity. The further out it goes, the more work it's doing, the less work it's doing here. So measuring this distance isn't really getting you anywhere unless you understand that it's not going to be linear. Fuckhead. Why is he catching it? Why doesn't he just let it go through a few times? The thing can record 10. So who knows? All right, fixed height to velocity. So fixed height for to velocity. I don't know what that means. But okay. See, I mean, if you let it roll off the top, then you can leave the marker there. We can all see where the mark is. Oh, fuck. So did he put a mark here where the first velocity was, the 60? I mean the 120. So now he's saying he's going to drop it from a height that's 60. This isn't a proposal. You're actually doing a fucking bullshit experiment and doing it again in bullshit pieces. Well, at least he figured out how to not have to catch it going through the timing gate. So that's going to be the last velocity. Where's the first velocity? 2, 3, 4. Seemed like it went through there more than 4 times. So it was at 62. Was the only first one I saw. It said 2. All right, so the first one was the first one. I thought before your recorder did the first last, but it's fine. All right, so whatever that is. So yeah, you mark it. Okay. So did we see you do any of that? No, but fine. That's the end distance. Okay. So the arc, he's pushed it against the wall and said this is where the wall line is. So obviously it's on a vertical, so if it reaches that vertical line, then he's half the speed.
So it should be somewhere around here is where you get 1/2 that velocity. So you have a 1 velocity, I don't know what to call it, pedestal. 1 velocity pedestal and a 2 and a 1/2 velocity pedestal. Now you know exactly what kind of speed you're getting. So now you can do the experiment with the 3 mass in the experiment. You do the experiment without bothering checking any of these velocities because you don't need to know this anymore. You just need to know the location of the pedestal. You just move the pedestal just a tiny bit back so the ball won't hit it. All right? And you see if this comes back to this half speed. So you drop it from the full height, the full velocity. All right?
I don't know. Why bother playing this? I understand my argument. Do you understand yours?
So let's say this velocity was 20, okay? Then you find the 10 velocity position. You move it just a hair back from there, so you have a good mark.
So he didn't do it the same way. So what's the point of what's the point of playing this video? Why doesn't he just explain the concept? Here, I have a mark for the half speed, and I have a mark for the full speed. Okay, and what we still don't have is any evidence of how much loss there is when it has contact.
And you do the experiment with the 3 mass connected, and you see if it comes back to the half velocity mark. And that'll tell you whether it has half the velocity.
So these look round. I don't know why the other ones didn't, but fine. But we don't get to see anything. We don't know how long are these pendulums. We can't, you're filming from one direction now, so but whatever. All right, they weren't touching, so that should also be noted. It's really not the best release method again, so sorry, but I mean, it's it really isn't. All right, so let's watch that again in the slow motion. Can we see any marks on the thing? No, can't see anything. I don't know, is this a mark here? It's hard to believe that would be the right mark, but whatever. Alright, so let's play it from there. Not working. See if that worked. There we go. Alright, so it goes well past whatever that thing is. Alright, now it certainly didn't go, so if the line is over that line, it certainly didn't go over it. Now again, the problem with this camera angle is the obvious distortion, parallaxing, blah blah blah. I mean, it should be over where you're actually, the only thing you're concerned with is you don't care about the big one, you just care about that small one. That one should be in the middle of the frame. So this is where it goes back 100. So you get everything back that you started with, almost everything. Now, see, you can't really tell from this angle, right? So you can understand that that's a straight line. And what you're viewing is it going across this line because it has a height to it, a dimension to it. So it's not the ideal way of doing this experiment. Obviously, crossing that baseline isn't the same as crossing it in space. So if the pedestal was higher, you would see the top of the pedestal, and that's what it has to cross. So if you can just imagine that this thing here is a flat, okay? It's against the table. If it was raised up to the arc, you'd understand that it's going to do the same thing this thing's going to do. That is, it's going to go past this bottom part, past its foundation. So understand that's what the real peak is. So again, it's just another distortion because you can't, whatever. Can't. All right. Well, anyway, he has another camera angle, so we'll see if that fixes this problem. But it's clearly deceptive because that pedestal, if risen up, would create a line further over. So again, if that's the line that it's crossing for half the speed, if that pedestal was raised higher, you would see the shadow on the actual side of the pedestal. But he didn't do it that way. So watch this. Alright, so these are his pictures now. So at least that camera angle is good. I don't understand again why he has this one cut so short. Why not raise it? Why not have it as the actual height that you dropped it from? But whatever. So he's saying this front edge was where he dropped that, he got half the speed from. That's his claim. And so just looking at it, just looking at the height difference, I tend to doubt it. All right. I mean, okay. I mean, something you can look at how the ball itself is pretty high off this surface. So he's got like 8 inches of, 6 inches of height between the surface he's measuring on and the ball. So why didn't he just raise the surface up right up next to where the balls are actually falling from? So I'd say it's a huge deception there. I mean, it just doesn't make for a great way to do the experiment. Not how I would have done it, that's for sure. I don't know why he still has the stupid sticks on it. Not using timing gates anymore. Don't even know if they went through the timing gate evenly. Look at how they're crooked when they hit. They're not even straight when they're flying in space. Obviously, if you go through if the stick is turned, it's wider than if it's straight. So if the front edge was supposed to be the mark, I don't think the front edge is, because now he's over twice the speed. Okay, and he certainly didn't make it to the back edge. So now you have to do this calculation for how much of a difference this difference is in terms of this total height. Like I said, that's why I would have just left the pedestal, because then you could see the top edge and you could see whether it goes over the edge or below the edge. But whatever. Alright, play it at regular speed, I guess. So this comes back full speed. I wonder, just in seconds, measuring how much time it takes, whether that's a possibility here, just because that does seem a lot faster. So that one came up about whatever, let's see, over the total distance, maybe 5% short. Alright, it perfectly bounces back to 1/2 velocity position. It says U. So that's past 1/2. But if you're saying this is the edge, then that's past 1/2. So somehow you made extra energy. So something's obviously wrong again, right? Because the theory isn't that it's, it produces this isn't supposed to be producing 200%. It's supposed to be producing 150, an exact amount, and you're over that. Whatever.
Now, it'd be even better if you have a pedestal for the quarter velocity also.
Yeah,
so because that's the one I'm going to say is going to be the truth. The quarter velocity is going to be somewhere around there.
Nope, it's not the truth. Here's the evidence. So where's the quarter pedestal? Oh, that's right, he didn't have it. So he plays a clip where I'm talking about it'd be even better if he had the quarter height. But again, he doesn't have them by height. He did them by wall surface, okay, which isn't the same. And so bullshit. So we really didn't see anything there, right? So he just takes images and doesn't show us, so we never get to see the damn thing running to see how well it performs, how well it conserves energy. Then, okay, well, again, I've already pointed out the flaws in the way he's filming it, so I'll just leave it at that. What's this? Oh, that's it. Okay, just a waste of extra video for nothing. Alright, so that was really shit again. Alright, frankly. Why can't you just do the experiment and show us what actually took place? Why do you have to do all this editing of everything? I mean, it wasn't that much to show, right? I mean, I could see it. Now, so it's the measurement that's the biggest doubt here. So that's the half the distance. Let's see. See which one this is. Well, forever. Play it. Try to pause it. So that's the 120. So that's the one going slower. All right. And he caught it. All right. So what we didn't see is, like I said, he didn't draw a good line here. There's no distance this way that we can see. But whatever. But there's no way he's supposed to be getting past this wall. So if that first line he drew is where this block was, well, he certainly didn't get to that. He went past it. And so how did he make extra? So anyway, I mean, I don't even know why. It doesn't even look like he actually hits the wall. So I don't know why he's afraid he's going to knock it over or something. I don't know. So anyway, it is, look, it's close to what I suggested, but it's obviously not the same thing. So I think it would have been better just to make proper measurements, get the center of the mass, create it, establish a height, and then have the two heights respectively easier to see. And but whatever. So this wasn't a proposal, but whatever. See what the comments say. All right, hats off. So that's the Brozo. And Ian and Michael too for continuing to debunk half-baked ideas. So the half-baked idea is you can't make free momentum. That's the half-baked idea. Okay, I agree with that. I don't know, says here, it's kind of hilarious watching it happen without me having to lift a finger. Haha, yeah, you're out of the show. You're superfluous waste. So you've achieved your true vocation in life, being a complete useless waste. So bravo. Oh yes, you've crossed every T. I mean, bullshit. All right. So anyway, nonsense. So we'll wait and see. Again, I'm just saying, what do you want me to say? That, oh yeah, I'm going to believe based on this piece of shit? Again, you're supposed to do the experiment in such a way as that you could write a paper proving it. Yeah. And if you're going to do that, then you shouldn't be proving something that shouldn't be happening, which is you went too far. You shouldn't be proving that. But whatever. Let's just play the when he actually does the hitting the 3 mass again. Okay, so it's perfect ratio. Yeah, sure it is. All right. Because the speeds are interesting. I mean, just visually looking at it. All this dead stuff in this video. So, I mean, this is really just, like I said, why are you doing this the hard way? Just let it, the hand release bullshit. Okay, so, let's see what happens from here. Yeah, there it goes. Okay, 1, 2, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 to there. So again, if that square, if this rectangle represents the half and the shadow is past that top, that's too much. I mean, maybe it's in the other side, actually. You know, maybe it's not making a good transfer to the other object. But they come back at the same time, so it's got to be pretty good. And it really bounces off. 1, 2, 3, 4, 5, 6, 7. Yeah, about 7 or 8. So it's the same frames, which is weird. But I guess, yeah, I have to think about it. Half the speed would be half the number of frames. Yeah, I don't know. So 1, 2, 3, 4, 5, 6, 7, 8. This is 9, 10, 11. You're stuck there. Yeah, I don't have to think about the frame part. But anyway, oakley doke. So, till the next time and such, probably. I'll pause and see if I have anything else to say about it. Alright, just a quick observation. This is where he's letting it go from the side view. And again, the key part of it is it's dropping, you know, at that, when it's against the wall and you're letting it go, that's when it's gaining most of its velocity. It's falling most of the distance it falls. It's falling right there. Before his hand is even out of the picture, it's already fallen more than half the distance it's going to fall. So, you know, you got to be really careful. So again, using his hand to release it, kind of bullshit. Whoa. Okay, well that was still recording? Well, that was a mistake then. I might have made a recording error. Fuck. Damn it. So yeah, I don't know if we're still recording, but anyway. I was thinking that, you know, I'm looking at that front line of that thing, and it does seem like it's almost half the distance. So I have to see if we can see it reflect where it actually does the hit in the video. So let's see if we still see that part. I don't know why this is filmed this way. It's such a strange... You can't see the rest of the thing. It's like it's blocked off for some reason. I don't get that. Let's see, get this to work. Yeah, so it did hit. So you can just barely see it hitting. All right, and so that place that's supposed to be, you know, half the velocity and 1/4 of the height, it does seem a way too forward. It should be back further because most of the height distance you're dropping is out here on the sides. So it should have a bias towards that direction, if I understand things correctly, because the flat part doesn't matter. So I think just from these images, you might be able to deduce that that's, you know, this line looks like half the distance between where it hits and this other wall. And it shouldn't be half the distance. It should be somewhere in here. I'm fairly sure of that. And they spin a lot and wobble a lot. So you can understand when he's using that timing gate, right? And these things, that little thing isn't exactly, it's not staying exactly perfectly flat. You know, it's got, you know, movement in it. That's not ideal. So when he was doing the measurement, since you're only measuring the one ball, maybe you could just measure the ball going through the sensor without the stick. See if we can, yeah, so there's the hit. So this distance, so the distance between this black line and this line looks like, if anything, it's more towards the center. And 1/4 the height should be more that way. So I'll have to go find the angle that it's supposed to be at. But yeah, that doesn't seem right. It should be here somewhere, not here. So that doesn't seem right at all. If it was that simple, if it was just half the distance, which that looks like. I mean, I don't know if I can bother getting my ruler out. And because the other line isn't a flat surface, I mean, the small line is going in this way, right? The small wooden pedestal is going in this way, and the other one's going out that way because of the stupid view of the camera. So that's kind of irritating. I mean, the parallax has the two surfaces not parallel. So the surface going this way for the one object, and the surface is going that way for the other object. And they, theoretically should be parallel lines, and they're not anywhere close. So anyway, another problem. All right, so we'll leave it at that. Yeah, there's a couple of issues right there. So I have to look. The Lewin video has the math on it, so it's just a matter of doing the math for the ballistic pendulum, and figuring out the arc versus the blah blah blah, the circle where half the velocity would be on a circle. All right. So, because I just don't think this angle's anywhere close to the right angle. This looks like an angle of 30 degrees, and I think it's supposed to be somewhere like 43. 30 degrees isn't 43 degrees. All right, anyway. So, till the next time and such and so forth and whatnot. See if I can fix this video. Alright, bit of an add-on. So I did take some images and superimpose them on each other, and that's about as good as I can do in this thing without making a mess out of it to make them larger. But you can see this is the starting position. This is where it first hits. This is where it stops, okay, at supposed to be half the speed, and this is where it returns. So this isn't the initial. So the initial would be a little higher, assuming, should be a little higher, because there's some losses here somewhere. So clearly it seems, that it's about dead in the middle, and I would argue that it's supposed to be definitely a bias in that direction. Okay. I can't mouse over this, so so that's not perfect. But anyway, I have the arrow somewhere, right? Yeah, there it is. All right, so I have to put the arrow up higher. Yeah, arrow higher. Thank you. Arrow at the top now. Let's see. Yeah. All right, so you can see the starting height here. This isn't much higher, as you can see, and then this is quite a bit higher here. So I didn't go out and figure out all these distances because this isn't really good enough quality. It's just too bad physicist Michael couldn't have done this with his 900 frames a second camera. But anyway, the idea is it should be, okay, 1/4 the height on a circle. It should be somewhere over here somewhere, is my argument. That would be 1/4 the height from the original height. Definitely should have a bias in this direction, and it's clearly not have a bias in that direction. It's almost that it has a bias in this direction, so it has a bias in the wrong direction. But you can see it's a pretty small amount of height difference between this, this and this. Not much. And then up here it's quite a bit of difference. So just saying, observationally, that isn't perfect. All right, so then we'll go through the other list of, I'll just go, I have a drawing, so I might as well do that. And, yeah, this is, all these experiments, there's a little bit of complexity to them. Oh, that's interesting. What the hell? How's it doing that? I don't know. Oh, it's a reflection. It's all this stuff catches you. So the point is, alright, so this is almost a circle. So this is the starting point and the center of the mass, you would argue. And so obviously as you move this way, okay, you're gaining very little height here. Here isn't going up much, right? There's a little curve. And obviously the curve gets steeper here. So you're doing less of this and more of this up. So that's where the bias should be. The halfway, half the speed should be biased in this direction. This distance between this line and this line should be smaller than the distance between the center, as you can see. And, I don't know, somebody's got to do the math, frankly. There's math that tells you this radius and all of this crap, but you really have to have the dimensions, the length of the radius of the circle. But anyway, you can clearly see it has a bias over here, and his result is here. That's where he's saying half the speed is, and it should be here, is my argument. It should be biased in this direction. So I think he is seeing 1/4 of the speed. Frankly, the images are inconclusive. I think a reasonable person should admit that, it's not exactly right. This and this is the difference we're talking about. So again, it's it's an experiment you got to do with some kind of precision, because it is a small difference, but it makes a big difference, But the basic argument, like I said, you can see from the pictures, there's no bias in this direction, and there should be. Half the speed should be somewhere more this way than that way. Yeah, so I think that's enough of a it's reason to not be too confident. Okay, I'm not saying it's not. Look, it's a good experiment. I'm glad he did it better than the other versions. Maybe just filming it, with a better view. I mean, if we get that's the disappointing part, is that you have all this parallax in these images. So let's put them back up. I guess we can. I don't think that any background's going to help here. I don't know if I can put them back up in the right order to be viewable. Yeah, they're almost viewable. So the argument is it should be, the bias is over in that direction instead of being in that direction. It really should be over a little further to be where I think the math says it should be. So it's definitely not half. And again, this isn't all the way. The starting position was probably a bit higher. So this image cheats to his advantage, not to my advantage. Because I'm going with the return impact at presumably the full velocity. But obviously it's hit twice. And so this is after it's hit twice. Position. This is after hitting once, and it's still got a bias in the wrong direction. Alright, so I think that's enough. But yeah, see, it's all these slanted lines. I mean, I can't, it's that parallax thing. It's just, the markers really should be sticks or something that are right in line with the pendulum, so there's no distortions in perspective. I just don't know how the best. I mean, maybe you could film it 3 times. Just do the experiment. No timing gates, no pieces of wood, no anything, and just put the camera so the end position is in the center of the focus. Then put the camera where this would be in the center of focus, and then the camera where the hit is in the center of focus, with the same background. Yeah, I don't know. You always need some kind of reference. But anyway, alright. So enough of a video. Till the next time, and such and so forth and whatnot. no, I gotta say a little bit more. I mean, the reason why I just find it impossible to believe is because it is free momentum. I mean, it just is, and it's so, it's so simple in terms of what you're arguing, and you're saying, well, why can't we capitalize on it? Because it's so much free energy. So the idea is you're hitting something with 100, you hit it into something big, 3, and now you have 150 going this way. I mean, the simple argument is the lever thing. I put a lever here, one distance, okay, 2 distances, I put the, well, I guess 3 distances, I put the 1 mass. You see all that? Yeah. This crashes in, okay, and I'm going to get 150 momentums out of here, presumably. Let's say I lost 25, then I still have 125. So I have more velocity than I started with here, and more momentum, of course. And I can just keep doing this, in the sense that I can just make this hit another lever, okay, at, yeah, I mean, I can hit another lever, or I'm just trying to think of how I can just take advantage of the same thing. I can put a 3 mass here, have it hit the 3 mass, and I'll end up with whatever, 170 or something, okay, in the 3 mass, and then have it hit another lever. And, I could just keep increasing. So even if I have a pretty substantial loss, 20%, I still have so much extra energy here that I could afford to throw some of it away. So I'm just saying I mean, if you're right, this is my patent statement, okay? I invented the free energy machine because it seems easily doable. I can keep getting more out of something than I put into it. I mean, come on. Momentum's a real thing. I mean, as much as you don't like it, it's still real. I mean, you have to consider momentum real. And if you're making free momentum, that's got to bother you a little bit. Come on. Doesn't bother you at all? Anyway. All right, so till the next time and such, that's enough.